Take a look. Example 8 has some trig in it. Find y prime if sine of x plus y is equal to y squared times cosine x. Okay, so implicit equation for sure, because we've got x's and y's in here. And then, so students have a tendency to want to use like some sort of trig identity to split this up, but we don't have to. We can, when we're taking the derivative of this thing, we could just use the chain rule and implicit differentiation. Over here on this side, of course, this will require the product rule. Product rule. All right, let's just get started, shall we? Take the derivative of the left-hand side. So I've got sine of stuff. The derivative of sine of stuff is the cosine of that same stuff. And now this is a composite function, so I need to take the derivative of the interior function. So term by term, derivative of x is 1 plus the derivative of y, I will write as y prime. It is saying, so I'm just using the same notation that they use, which is that prime notation, okay? All right, you'll see that it works exactly the same way as the Leibniz notation. Okay, on the right-hand side, product rule, derivative of y squared is 2y times y prime, boop, times cosine of x, plus y squared, the first one times the derivative of the second one, is negative sine. So I'm actually going to put the negative right out here, sine x. There we go. All right. Now, what we got to do is we have to isolate this y squared, or this y prime term, right? There's one over here on the left side. There's one on the right-hand side. Before I can get both of them on one side, I'm going to have to distribute this cosine x plus y through the parentheses there. So I've got cosine of x plus y times 1, pretend I did it, and then plus cosine of x plus y times y prime, and then just copy and paste this guy over here. Duplicate. Bam. What was that secret information? Okay. And then I'm going to switch some sides of stuff. Right, this is going to go over there, and then that's going to go over to the right-hand side. Okay, so I have cosine of x plus y. You know what I'm going to do? I'm going to factor, and I am going to subtract over my stuff all at the same time. Right, so I'm going to subtract over the 2y cosine x. That's what it's going to be, minus 2y cosine x. All of this will be multiplied times y prime. Did you get that? So I subtracted this term over, and in the process of doing that, I'm going to factor out the y prime, and you'd have 2y and then the cosine left over for that term. Okay, all right, and I have to subtract this one over, and it's going to meet up with this one. So a minus cosine of x plus y, and then minus y squared sine x. All right, only one left thing to do. What? Those aren't words that make sense. I just got to get rid of this. I'm going to divide that over here to the other side to get y prime. Y prime is equal to negative cosine of x plus y minus y squared sine x. All of this over, let's see, cosine of x plus y, and then minus 2y cosine x. All right, I think I'm pretty much done with that. I am curious what this graph looks like. Let's go ahead and take a look at it after I box my answer officially. Okay, and so let's pull up Desmos. You got that committed to memory? Sine of x plus y is equal to y squared cosine x. Good. Glad somebody does. So it was the sine of parentheses x plus y is equal to, throw in an equal sign in there, and then on this other side we have a y squared. Well, that was weird. Okay. Interesting. And then times cosine x. Ta-da! So you can see that this function is, this weird, strange function, is still periodic. It looks like these little pieces all fit together in a nice little puzzle. So it repeats over and over and over again. And then what we just found gives us, of course, the slope at any particular point. Maybe I want to find vertical tangent lines, maybe I want to find horizontal tangent lines, and so on.